Hello, we are here again in furtherance on how to use Excel to measure quantities. A recap on the last video, we dealt extensively with on the footings, and for the purpose of emphasis, we're able to extract the formwork, concrete, excavation, working space, backfilling, blinding, concrete, and the excavation for 3 footings on the drawing that we are referring to. And we're able to touch slightly on guts, on the trenches, which I feel we needed to discuss further on it for clearance, so that you can apply it and see if it is working. And for those that missed the first episode on this topic, you can visit my webpage at www.youtube.com/ quantity surveying made easy _2014. We have a drawing that we're referring to, which is a duplex. And as you can see, the drawings are gridded, both vertical and horizontal. And I was able to scale all the measurement of each of the grids for ease of reference. And we are going to start with the verticals. And as you can see, we have 1A, which is the grid 1A, and it's spanning from C to G, and the length is 6.115, and it has a B2 footing and 3 B2 footing, 1 at the center, 2 at the extreme. For me now to get the length of the excavation of my trenches, I need to take half of this footing off. I take half footing off from the end, and I'm taking all of this. Then I'm taking the working space of 600 to arrive at what I'm going to dig here. Then for the block work, I'm taking half of this column to bring me to the edge of the column here, and I'm taking half as well to bring me to this, and I'm taking away all of this. So because this portion will be occupied by column going up, so the block is not going to go through. After deducting this, I'm going to get my clear length for block work. Let us go to the drawing. This is 615. I have the column thickness is 150. I divide by 2, I'm having 0.75. Multiplied by 2, I have 150. Then the column at the center is C3, which is 350 by width. So I took out this. Then I come to then I will arrive at the length of my block work. I will arrive at the length of my block work, which is 5.65 as against the 6.1 that is on the drawing. Then for my base deductions, I have B2, which I have two half, one at this extreme, one at that extreme, they multiply by 2. That is why I see multiply by 2, then plus the one at the middle, plus 1.4, gives me this one. Then the working space is 4. I'm deducting working space for the middle has 2, while the 2n has 1. That's why 600 multiplied by 4. Then this is what I'm deducting from 5.2 from 6.2. 6.15. So what I'm left to dig is 0.95. 0.95. Then grade 2, there is grade 2, which is grade 2, which is B to C and G to K. B to C has one B2 column, one B2 footing at the end here, and has another B2 footing at the ends here. So I'm taking out a 700. I'm taking up a 700. I'm taking up a 700. I'm taking up a 700. Then I'll be left with. Then I will now take out 600. I'll take out 600 for the working space. I'll be left with what I'm going to dig here. Then equally on this other side, which is grid 2, G to K, I have one B3 at the center, and I have one C6 at the center. So I'm going to take out half the thickness of block, half the thickness of the trench, and half the thickness of the trench, and the full of this, and the whole of this column to get my block work. If you come to grid 2, you see 3.6. I'm taking 0.75, which is the thickness of the column. Then I am taking the whole of the column at the middle. Then I am taking the block work. But it's supposed to be, let's see if I am correct. I'm supposed to be multiplied by 2. Right, I'm supposed to take 225, half there, half there. So I'm having 225. For the same thing, this is for B. Sorry, we're correct. Then this is for GK. GK. I have I'm supposed to take I'm having this. I'm deducting this. So I'm left with my length for my block now is 63 6.3 6.39 6.39 as against 6.5 6.65, while my excavation is 1.4. What is remaining? 1.4 to be dug in that axis. So it is the same thing applicable. This is my own approach. You can approach it the way you have analyzed the result you want. So if my approach can be made easier by your own approach, it is good and fine. So it must not be my own, but it's just like a guide for you to understand what I am doing. Having said this, we'll quickly go to the other information. As you can see, I have the width of the trench here. I have the depth of the trench here. I have the height of the block here, and the height of the block. Why is it different from the depth of the trench? Because this is the depth of the trench. I took out the thickness of the strip footing, which is 225. I added a 450, meaning that the building is going to be above the natural ground level by 450. And the reason is because you don't know the level that the road network is going to assume. So for you to build and not elevate your building, the tendency for your building now to be beneath the road level is possible. So sometimes it can go as far as 600, 750, depending on. So that is why I have this 450, and now the height is now 1.48. Then having gotten this, then I have, for disposals, the thickness of the strip footing has occupied the space. So it has occupied the depth of 225. So now 1.25 minus 225 gives me 1.025. So as you can see now, I have the measurement of the trench will now be the length of the trench multiplied by the width multiplied by the height. Then why the earthwork support is the same length multiplied by this multiplied by 2 because it's two side. Then the backfilling is now this length multiplied by 680 minus 225, which is the thickness of block. Now you will now be left with 0.45. For ease of clarity, I can just do it so understand it. So I have 0.68 minus 0.225 gives me this. I sum them together. I have 0.44. Then I come back to my backfilling. I take out to 3. This is 1. When I make it 3 now, I make it 3. And so I now drag the formula down so that we can see how we arrive at the 450. You can see how we arrive at the 450. So this is the backfilling of the two sides of the block where the block work is running through. Then level and compacting is, of course, it is the length by the width. Anti-termite is the bottom and the two sides, which I took time to explain the formula in during the pit excavation. Then disposal, it is now the steps, this length by this one by 225, which is the size of block, which is the size of the thickness of the block by thickness of the block to get your disposal. So as you can see, if you drag your formula, if you add this to backfill, if you add this and backfill, you should be able to get 42.54, meaning that you're correct because it is the exact quantity that you excavated. And now you're taking the block, the area, the block, and the column, the concrete strip is occupying, and you're taking it out of the site and disposing that. So now, having done this, let's quickly go to reinforcement, which is what we want to discuss extensively for today. You know, I did said that if you're not given a bar bending schedule, you might be lucky to be given bar bending schedule where you just take the overall length, multiply by the quantity, and you get whatever you want. But a situation whereby you're asked to you are not given and you needed to show all the workings, how you arrive at the overall length and how you did the working using Excel. I know we all know how to do that using the manual method, but using Excel, that is what we are going to be discussing now. As you can see, I have my calculation sheet where I have B1, B2, B3. Then I have the columns C1, C2, C3 up to C5, up to C7. What I did is first I draw the base, which is going to your border line. I draw the base, which is equally what is here. Then I create this calculation area where I just needed to do is just to go go to the drawing. What are the sizes of the bases? We have 1.5, 1.4, 1.2. So I go to here, I just bring the first B1 is 1.5. I put 1.5 here, and cover by the information cover says you're going to take the covers is foundation is 50, column is 40. Then I put 50 here. I put 50 here by 2. It gives me minus 100 from 1.5. It gives me 1.4, which is the effective length. I click it, I bring it here, I get this. Then for deduction, for adding, I add bend, which is twice the diameter. The diameter is 212, diameter Y is by 2, by 1, which is 24. Then now for me to get the return, the upper return, it is 2 by 35. It is 35 here, 35 here, because the thickness of the base is 350. It's 350. I have 35 here, 2 by 35, 700. Then I'm taking out cover 4 places, because one up here, one up here, one up here, one up here, making 4 by 50 gives me 200. 200 by, so that is 700 minus 200 give me 500. 500 divided by 2, I have 250 here, 250 here. You do your manual computation, you see I am correct, because 350 minus 100, you're having 250. Then I link this by this, I divide it by 2 to get this. Then for me to get the number, since it is a square, it is a square reinforced footing. I click this, I took this effective length now. Then the center to center is 175. Divided by 175, I have 8 plus 1, making 9. If the footing is if the size of the footing is not the same, the size of the footing is not the same. Say, let's say this one is 2 meters. Let's say this is 2 meters. So now the only thing that changes here now is this one is this. Why this one is this. So now we are going to have two different numbers. We're going to have two different numbers, because the footing is not the same. It's rectangular. One side is longer the other. So you cannot multiply by 2 in this manner, because since it's a square both ways, so that's why I got this size and multiply by 2. But since it is now rectangular, you have to have 2 different bars, because their lengths are not the same, and even their quantity will not be the same. So you have this. So, but in the case of what we are dealing with, it is the same. So I delete this back. I click this. I pick this now. So the same thing I did on B2 1.4, which is the length, which is the length. I have this. Then I have 1.2. I deduct this and have this, and it is both ways. Then for me to draw this whatever, for me to draw this, I just want to show us how to still draw using Excel to draw your shape. Take this out. What I did is, you drag this, you close the cell so that the other one can, you just get go to your border, pick the size of what you want. Okay, then you come up here. Pick the size, take, then you go to your insert, you check shapes, pick this. Okay. So you can see you already have your shape of your reinforcement. So everything. You can use Excel to sketch some of the things you want to illustrate, you want to project, so that uh, the person interpreting your document will actually know what you're doing. Then, having done this, we'll now come to the column. The columns now are the columns now are this. You go to your drawings. The columns are going to project a starter. You're going to have starters above. Here they told us what the starter will be. But in the case where you need to use the conventional formula to get your starter is 50 by the diameter of the bar. So now what I did, and if you're not giving this return, the length of this return, there is a formula, universal formula that you can as well use to get your development length, which is 48D, meaning your measurement for your steel will take effect from the top of the concrete here up to the top of the concrete here. Then this, you're going to use 50D to get your starter. Then everything inside the concrete to the chair, you're going to use 48D to get it. So let us go to the sheet. From invert level to floor ground level, the length is 1.75. 1.75, and the bottom chair, I'm using the development length is 48 by 16, while the starter bars is 50 by 16. I have this. If you add this together, you have this. Then you now come here to deduct the footing, because your development length, you are supposed to take your effective length from the top of the footing. So this 768 now account for the 350 and the chair. So it gives you 780. Then you deduct this, you deduct your footing cover at the bottom, and you deduct your PCC, your blinding concrete. You have 400. 400, you are minusing this plus this gives you minus this. And the number of bars in the number of bars are in C1. C1 is 7. Number of bars in C2. C1 in terms of number is 7. The number of bars are 4. The number of bar in C2 is 4. The number of bars in C3 is 6. And they are all 16 dia bar. Here they are saying is 4. Why here they are showing us 6 bars, 1, 2, 3, 4, 5, 6. So then there's a discrepancy. If there's this C3, they are using this section 3, section 2, section 5. 3 is C2, C3. So if you have such discrepancy, you needed to get clarification from your consultant, because if it is, this is section 2.2, this is section 3.3. So meaning here we have for column type 2, we are having this section, which is 3 bars. Why column then for section 2, column type 3, we have 4 bars. So there's no discrepancies. So now we come to this place. I have 4 bars. Then the length is this 2.918. Then so I come to the stirrups. The stirrups is 350. I have 350 here. I am lessing bent is twice the diameter. The diameter is 8 mm. So minus, then you less cover 40. Twice 40, you have this for the longer side. Then for for the depth of for the header face, I have a 150 thick. Then I deduct all the deductible. Then I am supposed to add. I'm supposed to add bent. Add bent. So I'm supposed to then deduct. I add bent. Then I less covers. I now have this length. Multiply by 2. I have this. Then I have this return, which is this portion here. This portion here. 2 by 50 is 100. I add them together. I'll have 908 as the effective length. Then here is the span where the stirrups will occupy. That's 1.2. At 1.2, at a center of 150s, you have 8 plus 1 makes 9 number. So the same thing you repeat on all the columns. So if you understand this, you can do the rest columns. So what I did is, first I got this length, which is from top of the ground floor to the bottom of the footing. Then I added the starter. I added the development length. I deducted this the thickness of this column, the thickness of the footing, took off cover, and took off the PCC, and I arrived at the length. Here, see, there are discrepancies. They are giving me 750 as the starter length, while on this area they are giving me 675. So there is discrepancies. But for this emphasis, we're only just trying to educate ourselves on how to extract this and use the conventional formulas to get some of the missing information that might not be on the drawings. Like if the starters are not given, you have a conventional formula to apply. If the bottom here is not given, you take the development length from. I give you example. This is my footing. This is my footing. I'm supposed to take my effective length from here to the top of the grid slab. Then I will now use 48 times D by 48 to get from inside the concrete up to this point. And that is what I got here. So now we'll go to the bar bending schedule. You see, if you're working, there are projects where you're expected to submit your bill for payment with backup document, all the measurement sheets, checklist, bar bending schedule for checking, for proper checking. So if you can imagine, if you are in such a project and you needed to submit your backup sheet and you needed to prepare a bar bending schedule, you prepare your takeoff, and you're doing takeoff manually. You can imagine how taxing it is and how difficult it will be. And if there are errors, you start cleaning or you want to rewrite again, and you now start using your calculator to punch and all of that. But with the Excel, as soon as you discover any error, once you correct it, the whole thing will be corrected instantly. So that is why it is good you learn how to apply Excel in measurement. So now I draw the same shape. I press equals to, I go to my calculation sheet. Now I pick the effective length here, then I come to this area, I pick the 500 divide by 2. I have 250 this way. Then I click this side to pick this same 250 here, and I go to here, the number of footing, base 1. Where do I get it? I have to go to where I measured my basis. Where I measured my basis, we said the B1 quantity is 2. I click 2. Then how many number of the bars are in one footing? I go to it is 18 because it's both ways, and it is both ways 18 as against 9. If it is 9, I have to go there and multiply by 2. So 18. So equally now I have my 250 this way, then this one. Then I have my effective length as 1.9. Then the total length is the number of footing multiplied by number in each by 1.9. So the same thing repeated in base 2 and base 3. Then you go to your column, you pick this effective length, your stirrups, you pick the effective length, you pick the effective length, then you pick your 50 here, which is the return. So now you have all of this. This one twice is reflecting here and here. This one and this one is reflecting here and here. Then your returns this way and this way is reflecting 50-50. You have effective length of 908, and the numbers of columns are 7. You go to where you measure your column. C1 is 7. You click. Then how many numbers are the bars? You go to your foot 1 is 4 numbers. You click. So this is what you repeat for each of the till you get to see instantly. If you go to the extreme, you'll be seeing your quantity real time. You see your quantity Y8, I have 27.5 kg. That is then this other one I have 376.9 kg. A bit ton. Oh, sorry, kg. Oh, it is ton. Let's see if I have converted it to kg, from ton to kg. That is from kg to ton. So we'll be talking about 27. Let's divided it by you can see the thickness coming out. So let us quickly measure staircase. It is interesting if you use Excel to measure your staircase. See how small it is. You have finished measuring the 2 flights, the first and the second flight, in this small thing you're seeing on the screen. The first is you establishing this formula, which you get from the computer. You establish formula, you go to your staircase and get the information. The length of this is 3 meters. There are 10 risers by 10 tread. by 300, it gives you 3 meter. Then the height is 1.65. It's 11 risers. So I just come back to this area. I put 3 meter. I put 1.65. Immediately I have my immediately I have my the slope. I have the length of my slope, which is 3.42423. If you're doubting it, you can fact check me. Use your Pythagoras theory to check if the formula is correct. So 3 point. As soon as you get this, you go to your step. What is this span of the step, which is 2.85 divided by 2 to have one side of the flight. Then the beam length is 2.85. You have a toe. You have a toe under here, and your toe is 400 by 400, and your threads are 3 meter by 300 by 150 riser. So these are the informations you need. You come back to your toe beam length is half of the width of the step, half of the width of the stair hall, gives you 1.43, and the thickness of the toe is 40 by 40 by, then the concrete will be 1.43 by 40 by 40, gives you 0.23 cubic. Then the landing beam is 2.55. Let's check the landing beam. Landing beam is this 2.85. 2.85 minus 1.5 is now 2.85 minus 0.15. So you have 2.7, and the beam is 35 depth by thickness of 150, and the number is 1. Then the soffit, they are two because they are equal. They are equal. So this and this, they are the same length. So that is why I have two number here by this form, the answers from this formula, by the width, by that is the waist, which is a thickness of 150. I have 1.43 as the cubic meter for concrete. Then for the risers, it is 11. Then the width of the step is 1.43, while the tread is 150 by the riser 0.5. Then the formula change here, because that's why I have to put color here, so that I will not mistakenly drag this special formula here to another cell and get a bad result. So that is why if I have any special formula that I had put in a particular cell, I write it. So I see that color, I know that something special is about that formula. So that is why I colored it. You see, I took the formula and multiplied the number of risers by the width of the step by 300 by this, divide by 2. And why did I do that? Let's go to the step. It's like I took I took It's like me taking this rectangle and dividing it by 2 to get this concrete here, because I have measured the waist from this edge to the bottom here as 150. So I am taking this one separately. So that is what this 0.5 represents. So I'm taking rectangle divide by 2 to give me the number, the quantity of one thread, then by the number, which is 11. So I have 3 point. Then the landing, of course, is 2.85 by 1. By the thickness, I have this. Then the formula for the formwork, the toe is 2 sides. So it is the length by the height, which is supposed to be this, not the breadth, by 2. Then the landing beam is this is supposed to be 35, and this is supposed to be 1.15. So it's supposed to be, take this by the height, which is 1.8. Then the soffit is, of course, is the length by the width of the step. Then the riser in meter, the number by the width of the step, while the middle landing, like the landing is 2.8 by 1.8 and all. Then you want to get the edges of the landing. If it's not enclosed with the block, it will be this times this plus 2 times this way times 1.5 for the formwork. So as you can see, in less than in the space of 2 minutes, I've been able to measure my step, the formwork, and the concrete. What is remaining just the reinforcement, which if you apply this method I just showed us here, you'll be able to do that as fast as possible as well. So the next video will be discussing on how to measure finishing item. Another template which I've prepared, that what you just needed to do is just pick your information for the sizes of the room, put your information for the openings, and your quantity will come out. I hope I've been able to explain this better. But if you still find it very difficult to either navigate your way, just throw a question at me on my page. I will be able to respond. If it is what I needed to do a video to further explain myself, I will do a video and dwell on that aspect where you find it very difficult to navigate your way. Thanks for watching.